So our first theme is to look at the genetics of such crops to design enhanced cellulosic crop systems. And this means genetically maximizing the yield and the quality of the cellulose while minimizing inputs such as water and fertilizer, optimizing nitrogen use and the energy use for harvesting, drying and storage, etc. Our second stream is taking the feedstock and converting it to biofuels and bioproducts by biological conversion. The title of that theme is Carbon Capture and Conversion Through Metabolic Switching. It involves capturing the carbon dioxide into plant and microbial algal biomass and converting this biomass through biological catalysts, microbes and enzymes, into long-chain biofuels, biomaterials, chemicals, and energy. And the third theme, which is related to the second, is to convert feedstock to biofuels and bioproducts by thermochemical conversion. And the title of that is Thermochemical Mini Refineries for Water-Neutral Valorization of Agricultural Residues from Canada and California. So this involves pyrolysis and or gasification to produce chemicals and fuels. It includes an approach using mobile pyrolysis units developed in Canada to do an initial processing on site. So you can go to the farm, you can do a pyrolysis there using this mobile facility, which gives you oils which you can then take to a central refining facility, leaving the char perhaps to be put back into the soil. Feedstocks for biological and thermochemical conversion can include, for example, tomato residues, grape skins, apple pomace, flax and rice straw, or a variety of other sources. The action plan is to hold a workshop involving researchers, industry, entrepreneurs, and policymakers from Canada and California, and hopefully leading to an RD&D program with clear deliverables, and hopefully would include, or we'd make sure it include, a component of researcher and student mobility as well. It could also include the creation of an RD&D consortium or a Canada-California Institute for Biofuels and Bioproducts. And finally, we found a little bit of time to revise the call for proposals. So we did have a productive day. Thank you.
Continuing with the environment/energy theme, we're going to turn next to the Green IT Working Group. Stuart Wilson is the Vice President at ISTP Canada, which stands for International Science and Technology Partnerships.
Thank you, David. The Green IT Working Group was, in keeping with the Canada-California Partnership, was chaired by a triumvirate of Jerry Sheehan from the University of California in San Diego, Charles Despins from Prompt here in Quebec, and Bill St. Arnaud from Canary. It was quite clear in the discussions that both the jurisdictions are, as are other jurisdictions around the world, challenged by the global climate change, and ICT in particular is not immune to these concerns, which as a layman in these areas came to me as quite a surprise. And I'll throw out to you some of the factoids that I picked up during the discussions today. Did you know that the direct greenhouse gas emissions from ICT globally represent 2 to 3% of all global emissions? But those are doubling every 4 years, and the current emissions are about the same as the air industry, which gets a pretty black eye in terms of greenhouse gases. Unless there's changes made in the industry, by 2020, greenhouse gas emissions from ICT will represent 8 to 12% of global greenhouse gas emissions. During heavy use with your computer, in particular with the graphics processor working, that processor will draw energy equal to 4 light bulbs. So think about it every time you're doing your gaming. In Australia, they have a new plan they're putting in place to establish a new high-speed network across the country. The energy demand for that network will be equal to 4 new electrical generating stations. These are just numbers that floored me. ICT, applied in a research context, for every $1 of equipment that is purchased, it will cost $2 to operate both for the operating power and the cooling systems required. And lastly, a router, and everybody's business or university operation has dozens of routers. The average router, the carbon footprint for that is the same as an SUV. Now, I wrote SUV and I wasn't sure whether they said Hummer, but the bottom line is, again, it floored me, the carbon footprint of ICT. But on the positive side, both jurisdictions, Canada and California, have demonstrated leadership in environmental technologies, and that's all as background. Some of the solutions that were discussed in terms of R&D collaboration were using universities as test beds, because in essence universities are small cities. The example given was the University of California in San Diego with 30,000 students, and I would assume with all staff you're looking at 50 to 60,000 people within that community. And there's a need, and in particular within the test beds, looking at systems for metrics, both hardware and software. Other ideas that have been generated within this working group are the remote location of cyber infrastructure and computer hubs, network hubs, at the locations where renewable energy is produced, which often is remote sites, and linking these back to the user communities by optical networks. The basic concept being, rather than transport your energy from production to user, you transport your data flow, and you don't deal with some of the same issues related to energy loss over transmission lines, etc. And it keeps those energy production sites out in the remote areas. Another possible solution, there's software solutions that relate to utilization of ICT for monitoring of energy usage and emissions, carbon credits, offsets, and enforcement, etc. So that's the application of ICT to broader society. All of that led to a short but very insightful discussion on the call for proposals. In terms of scope, this group is looking at, for the call for proposals, two major themes. One is, how can the IT industry reduce its carbon energy footprint, which means how can they clean up themselves? And the second is, how can IT applications be used to a broader society and industrial area to reduce the carbon footprint? In terms of specific research areas, ones that were often mentioned or were higher profile were virtualization technologies, which you'll have to ask one of the other people involved who are more knowledgeable exactly what that means. I've had it explained to me, but I'm not quite sure I could regurgitate that to any effectiveness. Secondly, this idea of optical networks to allow better placement of cyber infrastructure closer to hydro or specific areas. In terms of collaboration structures, three basic structures were looked at or have been considered by this group, in particular before this meeting, but also reinforced